So my background, I work on business-focused data science projects and lead a team of data scientists working solely on the new analytics platform, which we want you to present this evening. I'm one of the primary users and contributor over the last year, starting really at day one. And Blair works as a senior data engineer in IT and at the same time in our data science division to enable us doing really cool stuff on the platform. In the next slide. So to the question, who are we and why are we presenting this evening? Well, at Statistics Canada, we're producing data and analytical outputs for Canadians in social and economic domains such as GDP and census for about 100 years or longer. And we are an organization of data analysts and statisticians. And recently, there was a major government initiative co-led by StatCan, Statistics Canada, to build a data analytics platform to enable our data scientists and those across the government to analyze and access data. And the main feature of the platform should allow for new machine learning and data science products to be rapidly deployed, those capabilities in the cloud on Kubernetes. So this whole initiative was especially fueled because of the urge of COVID-19, the pandemic approaching in spring 2020, and that's really the time when this whole platform and advanced analytics workspace emerged. And what happened then? All this happened through the partnership between different IT groups at Statistics Canada, working in the same team and same sprints, joined by our data science division. And Blair and I are part of this division, and we focus as a center of excellence on concrete business applications. Yeah, we enable and improve official statistics. We develop new products and automatize existing processes for internal and external government clients, and leveraging also close relationship with universities. And over the last 3 years, we grew from somewhat an internal startup to a full-fledged division of 35 plus people with diverse backgrounds. And most of them are data scientists. And our applications on that platform range from computer vision to natural language processing, and for example, to simulate the spread of COVID-19 through reinforcement learning. So we're doing a lot of cool stuff on this platform, and we want to share this evening how we got there, and hope that you have something to carry away this evening, and we're curious about your feedback. We leverage, as part of the platform, mostly open source products and services, which allow us to quickly create components of the platform, just such as Jupyter notebooks. And we work fully in the open on our Statistics Canada StatsCan GitHub organization. We use the standard open Scrum board methodology, in this case, to bridge the management, development, and the deployment operations. Also, our data scientists can quickly request new technology, report issues, and contribute with features through our GitHub platform there. And also another addition is that we use for Kubernetes infrastructure as a code via Terraform to allow for deterministic, reproducible stage management of all our services. And we have our Terraform blueprints available on GitHub as well. Now, I'm going to take a break, and I will set the stage for Blair to continue talking about core components and functionality.
Hey, I'm Blair. So I work with Christian in the data science division, but also on this sort of data analytics as a service project. So as Christian mentioned, the data analytics as a service project was for allowing collaboration with other government departments, academic institutions, like getting them access to this data while keeping the data very, very secure, right? So a lot of this data is quite sensitive, and stewardship of Canadian data is important. So doing this sort of the right way was really important. So over the last couple of years, we've developed quite a good cloud native team inside of the organization. So they work on this product as well as many other products. But we had been developing quite a bit of maturity in this sort of space. So people working with like Open Policy Agent, Istio, Vault, Helm, Infrastructure as Code, Terraform, GitLab, CI, all this kind of like automated scanning, all this kind of fun stuff, and good monitoring stack and all of this. So when this sort of data analytics as a service product or project came up, and especially when COVID hit and we were all kind of locked out of our VPNs and we needed like an analysis platform, the cloud native sort of team and this data analysis as a service project and the data science division kind of combined forces to work on this product. So we sort of set about it in like April, based on like a challenge from the chief statistician to put something together. And so we combine this platform using tools like Kubeflow, MLflow, in order to provide workspaces for data scientists using Jupyter, Shiny, these kind of tools, as well as leveraging some PaaS offerings like Azure Databricks and these kind of things. So next slide, Christian. Yeah, so as I said, it's built on top of these kind of things, but we are really focused on creating. We're somewhat cloud agnostic. What we really care about is using open standards. So things like Terraform are a great way of deploying these kind of services, but we provide things like S3 compatible object storage using Minio. So we're on Azure, so they don't provide like an out-of-the-box S3 compliant solution, but we can create one so that there's kind of a uniform interface, whether people are quite familiar with AWS, S3, or all these kind of things. So providing a uniform sort of API for people. And the Kubernetes platform allows us to sort of abstract away a lot of the challenges for data scientists, resource management, authentication. We're able to build a fairly robust platform with good monitoring solutions, kind of just at the platform level, so that it's kind of removed from what the data scientists need to manage, and it makes it much easier for sort of the platform team and the data science team to work together. Next slide, Christian. Yeah, and so in addition to things like the security aspects of things like Vault and all this kind of like credential management, it also provides good sort of cost analysis and monitoring solutions. So building on top of the standard like Prometheus, Grafana stack, we also have a tool called Kubeflow, which is just a product that we picked up. And so it gives the ability for every sort of data science project or group to assess, their resource usage on like a day-to-day basis. And we've even created integrations with KubeCost into a tool called Kubeflow, which I'm going to show you, before too long. So we try to make it really easy for data scientists who are not necessarily experts in the cloud. We hope that they spend their time on data analysis, not cloud technology. We want to make this always transparent to users. For one thing, because it's Canadian dollars being spent, so it's it's important to keep very good track of this kind of thing. So we use cost control measures like monitoring, but we also provide lots of platform level things like taints and tolerations in order to make sure that your GPUs are only being scheduled if you're actually utilizing a GPU for your workload. And the sort of scaling capacities of Kubernetes lets us sort of scale up and scale down quite dynamically so that people don't over provision resources. Yep, so next slide would be great. Yeah, but now I'll talk about kind of what we think is kind of the fun thing from sort of the data science division perspective, which is the tools that we use. So we created sort of a toolbox of services. So Kubeflow is an open source project that I think started with Google, but has sort of become an open source activity. MLflow came from the creators of Databricks, but it's a model lifecycle management tool. So you can sort of submit models or with metrics to this sort of model server. You can keep track of sort of the performance of them over time and create experiments using your models. So we use this to sort of, Christian uses it in particular for lots of sort of managing of his experiments. We use the Elk stack, so Elasticsearch and Kibana. Actually, I don't think we use the Elk stack. I think we use Fluentd, but we use those tools in order to well, for one thing, on the platform end, in order because it's a standard logging solution, but we also use it for sort of curating our own databases. So we do a lot of work with things like natural language processing sort of databases of textual data, and it's been quite a valuable tool for us there. It's also quite useful for BI things on unrelated experiments. So we've created, say, reinforcement learning projects where we sort of create a simulation that punches out an enormous amount of data, and then we can kind of gain insights about what happened by just loading that into an Elasticsearch database and then creating very quick visuals. So it's a really simple solution for creating good things. Selden Core is a thing that we really quite enjoy about this platform. So getting from having a model to turning it into like an actual RESTful service in as little time as possible is a really cool thing, and with as little sort of interaction with setting up infrastructure and these kind of things. So what Selden Core lets you do is it lets you produce like a TensorFlow model or like a PyTorch model, and you can create like a little custom resource definition that basically just spins this up on Kubernetes, creates like a set of replicas that you can load balance across. And I think Christian has used this in order to translate like millions of documents from English to French and other kinds of similar applications. So it lets you really like scale very quickly with sort of custom data science driven solutions, and lets you really sort of accomplish your workflows quite quickly in like a RESTful API driven way, which is very cool. We also have the ability to integrate with cloud PaaS services, so like Databricks and Azure ML, these kind of things. Yeah, so for those of you who don't know about Kubeflow, basically what Kubeflow is it's a little interface that sits on top of Kubernetes and lets individual users control their own resources. So users get namespaces, and you can also create like project namespaces. And inside of this, you're able to sort of self-provision, images, which are like Docker images basically, but for like RStudio environments, Jupyter environments, like VS Code environments, or sort of like desktop-based environments, like a VNC session kind of thing. But by doing this kind of at the platform level, we're able to curate some of these tools, make things particularly easy for data science, ideally, like pre-packaging a lot of things that make it easy for people to get up and running. Like TensorFlow works out of the box, PyTorch works out of the box. These kind of things, but we're also able to meet certain requirements that we have as the government of Canada. It's providing a service to Canadians, right? So providing bilingual services is one thing. So we've actually invested quite a bit of time in creating the French language packs for Jupyter Lab 3, which introduced internationalization just a couple of weeks ago. So ongoing efforts with things like RStudio. And we've actually written the internationalization for the Jupyter Lab Git and LSP extensions. So in addition to like creating, a very cool kind of data analysis sort of like workbench for sort of internal people, we're also trying to contribute back to the sort of overall community to make these services more accessible, bilingual, to sort of Canadians, which is pretty cool. Yeah, so Kubeflow pipelines also, Kubeflow also offers a pipelines kind of functionality. So it sits on top of either Argo or Tekton as the sort of workflow orchestrator. But Kubeflow pipelines provides just like a little Python SDK that lets you just write these in plain Python. And the aim is to really abstract away the idea of containers from the people who are working on the platform. You should not ever really need to think about these things. And Kubeflow pipelines provides a means of just sort of like automatically wrapping functions into sort of containerized modules and then tying them together. So you can create these kind of like workflows. So this is sort of a toy example of like Titanic data set kind of thing. But you can use these like very practically for like big batch jobs or recurring things like recurring web scraping runs that you execute, or even model management things. There's lots of data lineage and model management features that are built into Kubeflow. It's really designed to be like a full sort of workbench for the machine learning lifecycle, from like creating individual sort of interactive analyses inside of like a workbench notebook kind of thing, to sort of creating like a whole bunch of experiments, managing a whole bunch of experiments, and then tracking the lineage and the progression of the different outputs. So you can use it for automation, ingestion, model training, and of course it's all API driven, so you can connect it with external services too. Yeah, so I think I mentioned some of this stuff, but you know, another kind of thing to mention. So security, official languages, you know, accessibility. These are all really important things for providing a service, you know, as the government of Canada. And you know, I guess it's a fun little sort of anecdote here. Like when you know I started at the data science division, you know, not too long ago, but back in like 2019. A lot of this work was being done on air-gapped Linux computers for doing sort of deep learning stuff. So you know, providing a secure environment to do these kind of things, to provide innovative tools for data science. It's really about trying to like juggle the innovation with sort of the security guardrails that we need to sort of uphold. And so it's been a really exciting project figuring out how to sort of manage these two things, especially in the sort of work from home era, and figuring out how to provide these services in a way that's protected B, which is a government sort of term for like a data sensitivity rating. So we leverage a couple of cool tools for this kind of thing, like automated scanning through Artifactory and like JFrog X-Ray, and then Artifact, and then GitLab for sort of a lot of the automation processes in GitLab CI. Yeah, so that's all from sort of the high-level overview, but I'll let Christian actually show off some of the platform, so he'll get to do some point demo stuff.
Thanks, Blair. Thank you for taking the time to introduce the core components. Yeah, so now we could go and dive a little bit into different components. After all, doing some hands-on, this can be quite a difference, quite nicely to complement our slides. So let's go ahead. So our advanced analytics workspace is available for government employees. And you see here our landing page where we lay out the different services at hand. So our front-end team has done quite a good job, a very good job in providing those. And after the login, you can then choose the different environments you need for your project. This is here my workspace, Scratch space, where you see different notebook servers which correspond to different compute instances run with CPU, with specific images available for different purpose. And for us, it's very important to be cost effective and to have resources available dynamically as we need right away. And I can click together through a new server feature here in Kubeflow right away. The requirements, we have set up images which fit major workloads like geospatial analysis or other kind of Jupyter or R analysis. You select those, you select the amount of CPU and RAM and memory you need, and potentially GPU if the workload requires it. And then you can run the instance and try it out yourself. We have made it easier for new users to get started on this platform. Here I'm now connected to a Jupyter Lab instance image set up already with popular and useful tools for data science. You see here is Python, Julia, R, and even VS Code. After that, because we have hundreds of users joining on this platform, we have a quick start guide and different getting started scripts and notebooks for people to explore different core technology and just try out the machine learning on the platform. If I, for example, click on here, I end up with a Visual Studio Code instance, the server instance running here, and I can install extensions if I like and do proper coding. Alternatively, if I would want to work more with R, there's RStudio notebook server, which I can start and run. You see here, as it would be pretty much close to a normal RStudio environment. All this fits nicely together, and I want to demonstrate this on two examples. One is a computer vision problem or a use case at hand. So our goal was, can we detect construction starts of buildings across Canada on large-scale satellite images? And for this, the requirements were, can we build a software stack and deploy it and use it on that platform? So we built a Docker container with the software stack at hand, which we have used on multiple servers via CI/CD. And then afterwards, we have used here the object storage menu. This is just distributed storage available through our notebook servers. And there's we authenticate, so all our namespaces are isolated. So you can give access to spaces through our Kubeflow configuration. And here I'm exploring a couple of terabytes of satellite images, which I then can read in and process in a notebook server, for example, or Spark or whatnot. But we're not done. I mean, you start doing the deep learning work on Jupyter Lab notebook servers, as I showed earlier. And after doing this, you would want to analyze those. You pick a different image configuration, as shown earlier here in this template, and you start working to your geospatial analysis. You see here, this is one of our models here, which detects construction sites. So we can dive into those imagery from our object storage and look at the results. And as a data scientist, that's just awesome to do. So easy, accessible infrastructure. I don't have to worry about backend or scalability or such. Another project which highlights a little bit more other aspects is a project where we identify text. NLP, natural language processing, is such a popular topic and application case. Here we wanted to detect information in millions of documents. So we used Kubeflow pipelines. As Blair mentioned, you can set those up and configure them through Jupyter Notebook, which is super handy. I don't have to learn a new language. And here you see an example of a simple pipeline component, which does the processing, the deduplication of our articles. This is a major concern for one of our clients. And to load all the documents, we have centrally available as a service, Elasticsearch, as Blair mentioned. Here is Kibana accessing many of our documents. And now, one of the challenges we faced is that we have a lot of, we produce a lot of models throughout for different projects, and managing those across potentially different namespaces is not so easy, and keeping track of those. So we have the central MLflow instance running here, and I can now create experiments. And on my notebook servers, on which I have my compute instances, I can simply log my results, my models, and such on MLflow, and can compare those and share them with collaborators. Once I decide for a model, I can choose a deployment setup and say, okay, well, let's look at how I deploy that. In our case, we had the challenge. We had millions and millions of documents, and we had one of the machine learning models on MLflow. And how do we deploy it effectively and then allow us to scale it up effectively? And we leverage here best practices in MLOps. As you see here, the GitHub page where I just the workflow, I forked the result, our MLOps template, and then I configured the CI pipeline and the CD pipeline to via GitHub Actions to pick the model from MLflow and then deploy it via Helm chart on Zelden. And so the code is there, and it's in principle open available if you're interested to have a look. Alternatively, for testing purposes, here's a Zelden core template, which we use to test and then later on deploy our language model. Blair mentioned that we have a lot of articles in French and our language models are in English. And so we had to do a lot of translations, and we were deploying that Zelden instance you see here in locally in our project namespace, and that worked quite well. To wrap up things, the last tab I wanted to show you is the resource management. And here I'm really talking not about resource management for data engineers, but for data scientists. And we pick Grafana, which reads out the logs for Prometheus, and we track compute instance specific resources used. For example, I can pick here one of my notebook servers, and then I can track CPU usage, memory usage, and other over time, which allows me to be very cost effective and optimize pipelines. So I can also access pipelines, not just the notebook servers, if I like.
Do you have a process to ensure the quality or reliability of the data that you're getting, thinking in avoiding misinformation? What are the data sources?
Yeah. This is a very good question. We have yes, in order to we have in fact we have a necessity and proportionality framework which has been designed and implemented at Statistics Canada to ensure that the data we use is of appropriate quality, is being evaluated. We only use data which is absolutely necessary. We have a lot of experience over the last 100 years to deal with data of Canadians. And we have the uttermost care here to ensure that none of the data is, that we make the right decisions, that none of the data we use has issues with quality. We have, for all our surveys, we have a long process, a sophisticated process in place to do imputation, to check data quality. And the same processes can be also applied on the platform in principle.
For all those environments, VS Code, RStudio, do you perform backups of the code or asset created inside those environments?
So let's see. So that's a tricky question. So all of the environments themselves run in containers, so that if a security vulnerability ever comes out, we can patch them, that kind of thing. But then the directories themselves live inside of persistent volume. So your home volumes and data volumes, and then of course like your S3 storage and stuff is all good. And then we have Valero as just more on the platform level stuff that I don't know as much about. But we have Valero as a general sort of backup utility for snapshotting the different like disks.
Awesome.
Yeah, we had cases where we went up and down with the platform, because we had issues, and it's amazing how fast you can reset up the platform through Terraform.
Yeah, this is a fun story actually. So this platform, I think it got deployed in a week using the Terraform that they had been already building internally. So they launched it to a new environment in a week, which was pretty cool. And then there was one weekend where we discovered that we had built it on a subnetwork that ran out of IP addresses. So they had to deploy it to a new subnetwork, like a whole new Kubernetes cluster over a weekend without users noticing. And we did it.
That's amazing.
I saw COVID-19 cloud platform for advanced analytics was accessible to Statistics Canada employees and to other Government of Canada departments only, which is said in brackets, at least at the first stages of the development process. What parts of the analytical platform are available for the general public now? Thank you for the great work you do at StatsCan.
So I'm not the most qualified to answer that question because it's kind of a business question. But we have academic institutions, like we have some University of Sherbrooke researchers using the platform right now. So it's not limited. It's not limited to just other government organizations, other academic institutions as well. I think one of the sort of things is kind of like a technical thing. We do like Azure B2B authentication. So to individual Canadians, I think we haven't quite gotten there yet because we can't really confirm their identity quite as easily using like that kind of Active Directory thing. But any kind of a business that kind of owns its own sort of like authentication thing, I think that we have some flexibility to make it available.
Curious if you tried MLflow's deployment functionality and how it compares to Seldon.
Yes, it's a good question. Yeah, we to be honest, we don't have done a thorough comparison yet. This is something which is on our roadmap to do. I would say, yeah, we have different deployment options. There's not just that. There's also Kubeflow serving, which we also can use in principle. We decided for Selden Core initially because back then we didn't have the MLflow implemented yet, and we could do already servings because we had the Selden Core operator implemented, so you could already submit CRDs and for deployment. I think this is on our roadmap, and it will be very exciting to try it out and compare. If you have, by the way, any experience and we should want to have a further chat, reach out to me. I'm very excited to talk about this topic. Thank you.
How do you track data over time if it changes? Do you have a dashboard to visualize the imagery test set results?
To visualize the imagery test set results. Well, we always do, as part of the data science workflow, that we are analyzing validation and test set results, of course. I could talk forever about the methodology of how we validate our models, but it's very similar to what I have just shown. Yeah? We do analysis optically. Yeah? We look at the images and we compare the results of our detections. We do statistical analysis of the results. We have different metrics and KPIs to track the performance and according to our clients.